My name is Aida Marie Banyares Lati, Bachelor of Secondary Education, major in Science, first year, Block B. So, for the last problem, a uniform lead sphere and a uniform aluminum sphere have the same mass. What is the ratio of the radius of the aluminum sphere to the radius of the lead sphere? So first, since there is no value or any given information in the problem, but the density of the lead sphere and the aluminum sphere can be searched in the Google. So, the given for the density of the both sphere. So, the density of the lead is equals to 11.3 grams per cubic centimeter. And for the density of the aluminum is 2.7 grams per cubic centimeter. So, what is asked in the problem? So, we are required to find the ratio of the radius of the aluminum sphere to the radius of the lead sphere. Sphere to the radius of the lead sphere. So finally, we have the given and we already know what is asked in the problem. So, for the formula, I will be using the mass is equals to the density times the volume. So, since there is no value or given values in the problem, we will first get the volume of the both sphere, which is the lead sphere and the aluminum sphere. So, for the volume of the lead sphere is 4/3 pi radius of the lead cube. And next is for the volume of the aluminum sphere. It is same as 4/3 pi radius of aluminum cube. So now, since we have already the volume and we are already given the density, so we can calculate already the mass. So the mass of the lead is equals to the density is 11.3 grams per cubic meter times the volume, which is the 4/3 pi radius of lead cube. And for the mass of the aluminum, its density is 2.7 grams per cubic centimeter and its volume is 4/3 pi radius of aluminum cube. So next, since what is asked in the problem is the ratio of the radius of the aluminum sphere to the radius of the lead sphere, the next step will be the mass of the lead is equals to 11.3 grams per cubic centimeter times its volume, which is 4/3 pi radius of lead cube over the mass of the aluminum, which is the density is 2.7 grams per cubic centimeter and its volume is 4/3 pi radius of aluminum cube. So, as what we have observed here, we can cancel this and this one. So, what is left is its density only. So, what we'll do now is to have the radius of the both sphere. So, the radius of the lead cube over the radius of the aluminum cube is equal to, we will write down the two values left above, or the two densities of the sphere. So, for the lead, it is 11.3 grams per cubic centimeter over 2.7 grams per cubic centimeter. Next is we will cancel this. Since we cancel this, the next step will be R, or the radius of the lead over the radius of the aluminum is equal to 11.3 grams per cubic centimeter over 2.7 grams cubic centimeter 1/3. So for the next step, radius of the lead over the radius of the aluminum is equal to the cube root of the both density of the spheres, which is 11.3 grams per cubic centimeter over 2.7 grams per cubic centimeter. So first, let's get the quotient of the two values. So, radius of the lead over radius of the aluminum is equal to the cube root of 4.185185185. So this is the quotient of the two values. Next is to get its cube root. So radius of the lead over the radius of the aluminum is 1.6. So this is the final answer. Therefore, the ratio of the radius of the aluminum sphere to the radius of the lead sphere is equal to 1.6.